Factorize the following. X to the power of 4 take away 25. Now there are no numbers here other than 1, and there are no letter terms in this, so there's nothing in common. There are two terms with a takeaway sum in between, meaning we have a difference of 2 squares. So x to the power of 4, if we square root that, what times what makes x to the power of 4? The answer is x squared, so that is the first term that goes at the beginning of each set of brackets. Square root of 25 is 5, and we have 1 plus, and we have 1 minus. Now, just to point out here, when you factorize, you should always, if you have squareds contained in one of your factors, look to see if it can be factorized further. Now, in this case, that term, there are two terms, and the first one has a nice square root, but the second one doesn't. Also, we have a plus, so that can't factorize anymore. The next one, we have a difference. We have two terms. We have an x squared, which has a nice square root, but again, 5 spoils the party here, so it cannot be factorized further. So that is our final answer. For the next one, 36 take away y to the power 4. Two terms, nothing in common, difference between them, both have a nice square root, difference of 2 squares. Square root of 36, 6. Square root of y to the power 4, y squared. In order to get that negative, plus and minus times together. By plus and minus times together, of course, I'm meaning these last two terms times together to make that. Next one. X to the power 4 take away 1. Nothing in common, two terms, take away some in between, both have a nice square root. The nice thing about 1 is that its square root is just itself, so just even highlight that one for now. Square root of x to the power 4 is x squared. We have a plus and we have a minus. This term here, both of them are squares. There are two of them, but we don't have a difference in between, so that cannot factorize further. However, this can. That there is a difference of 2 squares within a difference of 2 squares. So this bracket, this factor, can be factorized further. What will happen there is that itself is a difference of 2 squares. Square root of x squared, x and x, square root of 1, 1 and 1. 1 plus, 1 minus. What we would have then is we still have this x squared plus 1 to begin with, and that there is this fully factorized. So always watch out, if you have x squared inside a pair of brackets, look to see if it can be factorized further. Next term. Nothing in common here. 9 and 25 don't share any factors. Only x's in the first term, only y's in the second term. Square roots of these are a bit more complicated to figure out, but they're still nice if you look at them individually. Square root of 9 is 3 and 3. Square root of x to the power 4 is x squared and x squared. Square root of 25, 5 and 5. Square root of y squared is y, so y and y. 1 minus 1 plus. Next thing we would look at is if either of the insides can be factorized. This is a difference of 2 terms, but not 2 squares. X squared is the only thing that has a nice square root. So there's nothing more that can be factorized. The fact that there's a plus here means we cannot even bother going there. But just because of the fact that there's an x squared here, it's worth looking just in case. Two of the trickiest types that you would see for difference of 2 squares. Just even talking about both of them individually, nothing in common, so we look to see if it can be factorized in a double pair of brackets. Both of them have 2 terms, although this one seems a bit more complicated. That is a term, and that there is also a term. Definition of a term being any part of an expression either side of a plus or minus, an open plus or minus. So this thing here is before the minus, this thing there is after it. These pluses and minuses don't count because they're locked up inside brackets. Anyway, I digress. For part E here, square root of 16, 4 and 4. Square root of x to the power of 8 is x to the power of 4 times x to the power of 4 will make x to the power of 8. And then the y squared will give us y and y. 121, square root of that is 11. Square root of 7 to z to the power of 4 is z squared. Squeeze this in here, and 1 is a minus, 1 is a plus in order to make that difference happen. Because of the fact that we have higher powers, it's worth looking to see if anything can be factorized further. I'm not going to bother with the plus in the second bracket because it just won't work with two terms. The second one, 4 would work, x to the power 4 would work, z squared would work for factorizing further, but the y and the 11 stop this from going any further, so we're done. Lastly, this one is trickier to spot as a difference of two squares, but like I said before, we have two terms, there's a takeaway sum in between, and the fact that both of these are written as something squared means they have a nice square root. The thing that is the square root of that squared is the thing that I've just wrote in the blue brackets. X plus 3 is the square root of x plus 3 all squared. Similarly, square root of 2x minus 1 all squared is 2x minus 1. These will then be the first and last terms of each set of brackets when we factorize this with 1 plus and 1 minus. Now, technically, that's it factorized. We've locked it up in terms of two factors there. We could, however, tidy up what's on the inside. In the case of the first one, because of the fact that we're just adding these things together, we don't technically need the brackets. So we have an x plus a 2x, which will make a 3x. We have a 3, take away 1, which will make a 2. So plus 2 like that. Second one, a little bit trickier. We do have to be careful, not so much for the first bracket. X plus 3 can just be written as x plus 3, but this negative before the red bracket is going to mean that everything inside this bracket is the opposite of what it was. So this positive 2x becomes a minus 2x, and this minus 1 becomes a plus 1. After that, the right-hand pair of brackets can be simplified. X take away 2x will make a minus x, and 3 plus 1 will make a 4, and I'm going to write this as 4 minus x rather than minus x plus 4. You'll see that sometimes the way that they write things in textbooks. Having a negative at the start of an expression isn't as nice looking, let's say. So that there would be our fully factorized answer. And also the inside of the brackets tidied up. Done.